My name is Charles Johnson, and I'm going to talk today about the work that my research group and I have done in publishing the PREDICT-HD dataset. This is a dataset that is a longitudinal study over the course of 17 years on participants that were at risk for developing Huntington's disease. The goal is to identify the disease in patients before they show symptoms so that we can give them treatment and counseling. Just as a quick overview of the data collected, this did run from 1999 to 2016 with over 1,300 participants and a large number of T1 weighted and T2 weighted images. These are MRI images, and we believe that this large number of data can be used for medical imaging analysis and the identification of Huntington's disease before symptoms show up. One important thing my lab did is conform the data set to the BID standards so that it can be used by the medical imaging community as a whole. Another thing my lab did is ensure the quality of the images that we published. We threw out images that were of too low quality to be effectively used in any medical imaging analysis. Further, we de-identified the data being published so that participants would have their privacy maintained. One aspect of de-identifying was a defacing software that we applied to each of the images. As you can see, that cuts off any imaging data below, pretty much below the brain, and blurs the mouth and nose. Additionally, we shifted or changed the dates and times. In the times, they were rounded to the nearest 15 minutes. For dates, they were shifted such that the first MRI scan occurred on January 1st, 2000, and then all of the subsequent scans were shifted accordingly. We also removed any words that could potentially link the data being published back to the PREDICT-HD study to protect the privacy of the participants of the PREDICT-HD study. Additionally, we identified landmarks throughout the brain using our custom software tool called Brain's Constellation Detector. This first ACPC aligned the brain and then identified 51 fiducials throughout the brain that can be used as landmarks and helps the further analysis of this dataset.